Hello YouTube, welcome back to Information Tech with Dave. I know I haven't put out a video in quite a while, had some things going on, but I'm hoping to dive back into that. So today, what we're going to talk about is network device discovery with ARP. And ARP is, like many things in IT, an acronym, and it stands for the Address Resolution Protocol. Before we get started, one of the things I want to address is, can't this knowledge be used by hackers? And yes, that's definitely true. Unauthorized hackers who get onto your network can use ARP, the protocol, and ARP related tools to discover hosts on your network that they might want to target. That's very true. But you need to know about them because A, they're going to be trying to use them, and B, a lot of these are installed by default on systems. So you have hacking groups that like to live off the land, especially what are called APTs, or Advanced Persistent Threats. They rely on them because it's a way for them to avoid detection, which can be triggered if they try to install something new on your network. One of the most significant APTs that targets telco networks, especially here in the US, is something called Salt Typhoon, and that's actually affiliated with the Chinese government, so it's a major concern. So if you're a network administrator, or if you're on a blue team, cybersecurity defense team, you need to understand these. And you can also use them to discover unauthorized hosts that have been connected to your network. So these are very powerful tools. And as you can see here on screen, I've got a quote from Sun Tzu, who wrote in The Art of War, about how you need to know your enemy and you need to know yourself, and the results that you're going to get if you know the enemy and yourself, or if you know the enemy but not yourself, or vice versa. This is some really ancient wisdom, and it's directly applicable to cybersecurity. And what it boils down to is that, like any other tool, how it's used matters, intent matters. So let's dive in. Also want to note that this presentation is going to be Unix focused. That means that the tools that I'm going to demonstrate run on Linux, macOS, and BSD based systems. If you are a Windows user, what you can do to get access to these tools is you can use the Windows subsystem for Linux, or you can install a Linux virtual machine in something like VirtualBox or VMware Desktop, that sort of thing. But we are going to primarily focus on Unix operating systems today. So before we look at the different tools, let's discuss a little bit about what ARP is and what it does, and basically why should we care. So ARP is a networking protocol that works at layer 2 of the OSI model, which is something hopefully you're familiar with. I may do a video on this a little down the road, but it's a 7-layer conceptual model that helps you understand how networks function. It's not like you're going to go into a data center and point at a router and go, that's an OSI model network. It's not that. Again, it's a conceptual model. And the layer in this that we're going to be focusing on is layer 2, the data link layer, because that's where ARP works. It maps physical addresses, also known as MAC addresses. MAC stands for Media Access Control, to IPv4 IP addresses. It does not work with IPv6. IPv6 has other protocols that it relies upon for this function, so we're not going to talk about those today because it's outside the scope of ARP. And something that's important to know is that ARP packets and resolution is confined to a single broadcast domain on a network. So it doesn't cross routers, it's confined to a single subnet or VLAN. And the way ARP works is it makes a request and then gets a reply. It's pretty much a simple 2-step process. Step 1 is if a host needs to know what IP address or what the physical address of another host on the local network is. Host A is going to send out an ARP broadcast, and it's going to basically say who has the IP address of, for example, 192.168.1.10. If a host doesn't have that IP address, it's going to ignore it. If your host B does have that IP address, it will reply with a short message saying, I have that address and here's my MAC address. And that facilitates local communications on a network. So why is ARP useful for device discovery? It's because it's a fundamental component in how local networks function. For devices to communicate on a LAN over IPv4, they have to respond to ARP. Many devices are set up so that they ignore ping requests or ICMP packets, but even devices that are set up like that or have local host firewalls that block most communications are going to reply to ARP packets, because failure to reply to ARP packets pretty much breaks functionality. So we'll look at a few different tools listed here. There's ARP, which is a system command as part of the NetTool suite. It's currently being deprecated on Linux, but it's still used on macOS. Then we have a few tools: IPNeighbor, ARPScan, Nmap, which you may be familiar with from working with it at higher levels of the network stack, NetDiscover, TCP dump, and then finally we're going to look at a place online that you can use to look up MAC addresses based on their object unique identifier. So let's first take a look at ARP, and we're going to do this on my MacBook, and I'm going to copy and paste this command into my terminal, and you can see I don't need to run this with sudo privileges or elevated privileges. I'm specifying the interface that I'm using, which in this case is my wired interface, and then -A for all. And so this goes through, and this shows all the different devices that are currently seen by my MacBook. And there's a reason that we want to specify the interfaces, because if you don't, if your device has more than one interface, you may get multiple, or essentially you get duplicates. So let's clear this out, remove the interface specification, and look at this. We're getting a lot of duplicates. Let me just grab this one. This one is seeing the IP address 10.0.0.241 with the specific MAC address of BC 2411 AA 57 or 59.7, and it's showing that it's detecting it on my wired interface ENO0, but it's also detecting it on my Wi-Fi interface EN11. So this is good to know, and what you may want to do is actually run it on both interfaces individually, so that it's a little bit easier to parse this information. So if we go back up to my first command, modify it a little bit, you'll see that we don't have duplicates, but this is what Wi-Fi is seeing. And if it's coming up something like this, it means it didn't find anything. So let's move on to the next tool. So this one is one that we're going to run on Linux. So what I have is I have another terminal session open, and this is I'm secure shelled over to a Linux virtual machine running on Proxmox. let me just type, wrong terminal. You can type in the full command, ipneighbor, or you can just type in this abbreviated version, ipnay, and you can see this is what it's seeing. And we can compare that to what we saw over here. There we go. And this demonstrates that if you're on a switched network, which is going to be pretty much everything nowadays, you may see more or less results depending upon the network port that you're connected to. So something to keep in mind. So the next tool that we're going to look at, and we can run this on both Linux and Mac, is ARP scan. And something that you may need to do, depending upon how it's installed on your system, is you may need to run it actually as root rather than using sudo. And I'm going to show you why. So here we are, SSH'd into a Debian VM. I do it using sudo, which you would think would get you all the privileges you need, but because of the way that it installed a couple of files, I'm still getting permission denied. So if I become root, and I issue the same command, let's clear this out. Now again, I'm running as the actual root user. I don't get those errors about not being able to open those two files, and so that gives me better results because it can actually look up the different identifiers. You see here the results. I didn't get the manufacturers, but when I ran it as root, I actually was able to look up the different manufacturers. So just a little quirk of this particular tool you should be aware of. So we're done running things as root. I'm going to log out, get back to my regular Dave user. Now, on the other hand, we can also run this on Mac. And on Mac, the way that I installed it, it does work properly if I run it using the sudo command. So this demonstrates that you can, you may have different quirks on how you need to run this. If we go up here, we get the different, outputs. Here's, I ran this as sudo and didn't have the right permissions over on the Linux side. I had to log in as the actual root user, but over on the Mac side, using sudo gave me good results without any permissions errors. You can also use Nmap. Nmap's a really common tool for network administrators and cybersecurity people and hackers. And what you can do is essentially you can run a ping scan, not a ping scan, but you can run an ARP scan of your local network or a particular VLAN, and it will then give you the hosts that it finds and report their MAC addresses. This takes a few seconds. And you can see here, scroll up to the top, it goes through, it does scan, shows you the IP address, tells you that the host is up, gives you a little bit of information about latency, gives you the MAC address of it, and it gives you the manufacturer. And here it shows you that it scanned the full subnet and how long it took, which, 5.08 seconds is not bad. NetDiscover is a program that you can use on Linux. It can be used actively or passively. It was originally intended largely for use on Wi-Fi networks, but it also works on wired networks. It can actually work on networks that don't have a DHCP server, and if you use the -R option, you can specify the scan range, and you can use the -I option to specify your network device if you need to do so. So what we'll do is we'll hop on over to our Debian VM, and I just pasted it into the Mac. Don't need that. Here we go. So again, sudo netdiscover -R, and then the range is my local subnet given in CIDR notation. And this is just a thing from iTerm. And you can see that it's still actually running, but it gives you this really nicely formatted output. And so you get the IP addresses and the associated MAC addresses, how many ARP packets it's getting from each particular host, length of those packets, and then it gives you the Mac vendor, and it may be able to give you the host name. In this particular instance, I'm not getting that. And then you can just let this run, and then it may discover additional hosts, or you can just hit Control-C. That kills it. But now you've got this really nicely formatted output that can help you track down devices on your network. The next tool, and I think this is the last one here, is TCP dump. This is a tool that's very commonly used. It's relied on by some other tools. For example, Wireshark uses TCP dump to do the actual packet captures. It's useful to be able to do this from the command line for your packet sniffing. For example, if you don't have a graphical user interface on a server, you can use TCP dump if you need to do a packet capture. So what we'll do is, again, we're going to paste our command into it. Let's clear out this. And you'll notice that I'm running it as super user. And the reason for that is because we need to put the network device into promiscuous mode. So command TCP dump, we're specifying our interface here. We're specifying that we're only going to capture ARP packets, because if we don't do that, I'll show you why. Look at that. Let's quick hit Control-C. This is capturing not just ARP packets. There's tons of SSH. There may be others in there as well. You do this long enough, it'll probably be like DNS and NTP and all sorts of other things. So go back, and we have a filter set up so that we only capture ARP packets. We can also set it so that we limit the number of packets that we capture. Here we're going to capture 30. -V means it's in verbose mode, so we're going to see what it captures. And we hit that. And this is real time. This is live. This is what is actually seen on the network. And then after this captures 30 packets, it'll automatically stop. Or you could hit Control-C. So we can look at this and see a lot of information here. I'm just going to kill this. So we captured 28 packets. First thing here in the first column, this is a timestamp, down to the very tiny portion of a second. Shows that we're capturing ARP. It's on Ethernet. And you can see here, this is a pair. There's a request and a reply. So the request is coming from this host .163, and it's asking what the MAC address of .1 is. And then you can see in the reply that it says 10.0.0.1 is at, and then it gives you the MAC address. And in this case, we're getting that OUI unknown. And what I'm going to do is I'm going to copy off the MAC address because it's going to be relevant on our next slide. Go to the next slide. This is where you can search for device manufacturers. This is a web page. It's one of many. You can find plenty of them on Google, but MAC addresses are assigned in ranges to device manufacturers. And that comes from IEEE. One of those sites is OUI.is, which I have conveniently loaded in this tab. And we're going to take that MAC address, which showed up as unknown, and we're going to search for it here. And you can see that this site has a more comprehensive database, so it was able to identify the manufacturer of the device with that particular MAC address. And this, if you remember, this was 10.0.0.1. That's the local interface on my cable modem router. You can see here it was made by Vantiva USA. This shows you the MAC address prefix, and then this gives you a MAC address range that it's a part of that was assigned to Vantiva, and that comes from this particular registry here. Click on that, and it gives you some information about that registry. So that's it. Let's take a look at what we learned today. ARP is a layer 2 protocol, works at layer 2, the data link layer, the OSI network model. That's below most common network protocols. We looked at a bunch of different tools that you can use to discover network hosts via that ARP protocol. But we saw that depending upon the tool that you use and the network switch port that you're connected to, your results may vary. So don't rely on just one port. Don't rely on just one tool. Use a combination. Because MAC addresses are unique and ranges are assigned to device manufacturers, if necessary, you can go online and find out who made them. That can help you track down devices on your network. It'll help you determine whether or not that device belongs on your network. And finally, leveraging ARP tools and the ARP protocol can facilitate you discovering hosts on your network that may escape other detection tools. And that's it. So thank you for watching. If you want to, you can grab a copy of this slide deck for future reference off of my GitHub address right there. If you like it, it would really help the channel if you hit subscribe and the notification button. And then finally, please share the link for this video with anybody who you think would find this helpful. Thank you for watching, and I hope to see you soon.